It begins not with a bang but with a whisper, a silent digital pulse rippling through the planet's synthetic nervous system. Deep within the protected heart of Vienna, within a global data fusion center that never sleeps, a single flag is raised. It isn't a flash of red light or a blaring siren. Those are for crises we already understand. This is something else. This is the quiet, algorithmic intake of breath before a discovery that could reshape our world. This is the moment 3I, Atlas, the integrated, intelligent, and immediate atmospheric tracking and location system, detects a ghost. Across a network of hypersensitive listening posts scattered like sentinels across continents and oceans, from the desolate ice sheets of Antarctica to the volcanic peaks of remote Pacific islands, a specific signal has been unanimously confirmed. These stations are our planet's watchtowers, designed to hear the inaudible, to see the invisible. They are not looking for missiles or listening for explosions. They are sniffing the wind. They are tasting the very air you and I breathe, passing it molecule by molecule, searching for the telltale signatures of humanity's most terrible creation. And today they have found one. The message, stripped of all ambiguity and distilled to its terrifying essence, flashes across secure terminals worldwide. High levels of Xenon-135 detected. An anomaly of profound significance. A concentration far exceeding any natural background. To the uninitiated, the name is meaningless. Xenon, a noble gas, inert, unremarkable, a minor constituent of our atmosphere, used in specialized light bulbs and anesthesia. But to the physicists, the intelligence analysts, and the global security strategists, who are now being silently awakened in the dead of night, that specific number, 135, is a thunderclap. It is not just an element, it is an accusation. It is the unmistakable, irrefutable fingerprint of a nuclear fission event. And not an old one, not some dusty echo of a Cold War test drifting for decades in the stratosphere. No, Xenon-135 is a fleeting radioactive ghost. It possesses what is known in nuclear physics as a brutally short half-life, just over 9 hours. This means that half of whatever amount is created simply vanishes, decays into a more stable element in the time it takes to fly from New York to Tokyo. For it to be detected by our global network in these quantities means something has happened. Not last year, not last week, it has happened within the last day. Somewhere on this Earth, a catastrophic event of immense nuclear power has just unfolded, and this invisible, odorless, tasteless gas is its silent scream carried on the global winds. It is an atomic stopwatch that has just been started, and its ticking hand is the frantic decay of these very atoms. We are not looking at history. We are living in the immediate unfolding aftermath. The evidence is not cold. It is radiating still warm from its creation. This isn't archaeology. It's forensics conducted on a planetary scale for a crime whose nature, location, and perpetrator are for now a terrifying void. To truly comprehend the gravity of this signal, you must journey with us into the heart of the atom, into the violent alchemy of the 20th century. Imagine a single, impossibly dense nucleus of uranium-235 or plutonium-239. It sits in a delicate, precarious balance, a celestial body in miniature humming with immense potential energy. Now imagine a single neutron, a subatomic bullet fired with precision into this trembling core. The impact is not a simple collision, it is a cataclysm. The nucleus absorbing the neutron becomes fatally unstable. It cannot hold itself together. In a flash of unimaginable energy, a release of power that reshapes matter itself, it shatters, it fissions. This is the act that defines our modern age, the fire stolen from the gods of physics. But what is left behind? The energy is blinding, the heat is infernal, but the true evidence lies in the ashes. The original heavy nucleus does not simply disappear, it breaks apart into two smaller, lighter nuclei. These are the fission products, a chaotic spray of elements born from the original's destruction, and it is here in this storm of newly forged isotopes that our story takes its dark turn. The debris is a veritable witch's brew of radioactive materials, strontium, cesium, iodine, each with its own unique signature, its own rate of decay, its own poisonous legacy. Many of these isotopes linger for years, decades, even millennia, becoming long-term contaminants, the persistent toxic ghosts of nuclear power. Iodine-131, for instance, with its 8-day half-life, was the dreaded spectre of Chernobyl, concentrating in the thyroid glands of children and spreading cancer across a continent. Cesium-137, with a 30-year half-life, still renders vast tracts of land around Fukushima and the Chernobyl exclusion zone uninhabitable, a radiological scar on the planet that will outlive us all. These are the familiar villains of the atomic age. But Xenon-135 is different. It is ephemeral. It is the smoke that appears nanoseconds after the gun is fired and which dissipates almost as quickly. It is produced in enormous quantities during fission, a direct and immediate consequence of the atom's violent rupture. Its existence in the atmosphere in any significant concentration is therefore unnatural. It is a profound violation of the Earth's chemical equilibrium. There are no natural geological processes, no volcanic eruptions, no bizarre cosmic ray interactions that can generate xenon 135 inches, the amounts our network is now seeing. Its presence is a stark binary message. It signals only one of two possibilities, each more frightening than the last. The first is a major reactor accident, a core breach, a meltdown, a catastrophic failure at a nuclear power facility that has released a plume of its freshly created fission products directly into the atmosphere. It would mean a new Chernobyl, a new Fukushima, a disaster unfolding right now somewhere we cannot see its radioactive breath already reaching our senses. It means a population is in peril, a landscape is being irrevocably poisoned, and a government is perhaps desperately trying to conceal a failure of terrifying proportions. The second possibility is in many ways even more chilling. A nuclear detonation, the deliberate weaponized use of fission. An atmospheric test conducted in flagrant violation of every international treaty, a brazen act of defiance against the global order. Or worse, something far more sinister, the clandestine test of a newly developed weapon by a rogue state or a terrorist organization that has finally crossed the ultimate threshold. The signal doesn't discriminate, the laws of physics are impartial. The Xenon-135 produced by a peaceful reactor and the Xenon-135 produced by a city-destroying bomb are one and the same. The ghost in our machine carries no political allegiance. It tells us only times what times has happened, not times why asterisk. And so the hunt begins. In quiet, secure rooms around the world, supercomputers are now roaring to life. They are fed the data from the 3I Atlas network, the precise time of detection at each station, the exact concentration of the isotope, the prevailing wind speeds, and the complex chaotic fluid dynamics of our planet's atmosphere. They begin to run inverse transport models, a form of computational black magic that attempts to rewind time. They are trying to trace this invisible river of gas backwards from the countless tributaries where it was detected all the way back up its stream to its single unknown source. The models project possibilities, painting vast swathes of the globe in probabilistic colours. The origin could be here in this remote desert, or perhaps here in this dense industrial corridor, or here in this empty stretch of ocean. Every minute that passes, the radioactive evidence literally dissolves. The Xenon-135 atoms are decaying, transforming into Cesium-135, erasing their own tracks. The atomic stopwatch is ticking down, and with each tick the signal grows fainter, the plume disperses wider, and the chance of a precise triangulation diminishes. It is a race against the fundamental laws of nature, a high-stakes investigation where the key evidence is actively destroying itself. For the teams of scientists and analysts now staring at these evolving maps, the pressure is immense. The fate of millions and the stability of the entire world could rest on their ability to solve this puzzle before the ghost vanishes completely. We have built this system, this global web of sensors, for this exact moment. We built it in the shadow of the Cold War, after decades of atmospheric testing had scarred our planet and our collective psyche. We learned from the fallout of those tests, from the radioactive rain and the poisoned milk, that the planet is a closed system. We learned that an event in one hemisphere could have devastating consequences in another. The comprehensive nuclear test ban treaty signed by nations across the world was our promise to ourselves never again. The monitoring system, with its seismic hydroacoustic infrasound and radionuclide stations, is the treaty's ever-vigilant watchdog. It is the physical manifestation of our hope to keep the nuclear genie bottled. And for decades, it has held its silent vigil, tasting the air for the faintest hint of a broken promise. Until today. Today, the watchdog is not just stirring, it is sounding an alarm that resonates through the highest corridors of power. The detection of Xenon-135 is more than a scientific curiosity. It is a geopolitical crisis in the making. It is a direct challenge to decades of non-proliferation efforts. The invisible cloud currently drifting across borders is also drifting across the fragile lines of international trust. It carries with it the seeds of suspicion, of accusation, and of fear. Is a friendly nation hiding a terrible accident? Is a rival power engaging in a dangerous provocation? Has a threshold been crossed that can never be uncrossed? The silence from the world's governments is for now deafening. No nation has claimed responsibility. No nuclear agency has reported an incident. No seismic sensors have picked up the telltale shockwave of a confirmed detonation. This only deepens the mystery. A reactor accident of this magnitude would be nearly impossible to hide from satellite surveillance and on-the-ground intelligence. An atmospheric detonation would have been seen, heard, and felt. This suggests something else. Something clandestine. Something that was meant to remain a secret. The Xenon-135 signature is the trace evidence of an event someone did not want us to see. It is the one mistake they made, the one clue that escaped their containment. You are now part of this investigation. We are all breathing the same air, all living under the same sky through which this radioactive messenger now travels. The alert from 3I, Atlas, is not just a warning to governments. It is a notification to all of humanity. It is a reminder of the awesome, terrible power we unlocked just a few generations ago, a power that continues to simmer beneath the surface of our civilization in reactors and in warheads. The question that hangs in the air as thick and unnerving as the plume itself is not just technical, but existential. What has happened? Where on our fragile, interconnected world has the atom been broken? And as we follow this ghostly trail back to its source, what new terrifying reality are we about to uncover? The search for answers has begun. What if the most profound secret humanity ever unlocked was not a message from the stars but a whisper from our own atoms, not a promise of creation but a formula for absolute annihilation? In the summer of 1,945 inches, a desolate stretch of New Mexico desert, we turned that terrible key. With the Trinity test, we didn't just split the atom. We fractured our own history, dividing time into a before and an after. In that searing, manufactured dawn, we unleashed a power that could scorch continents and erase civilizations. But we also unleashed something else, something far more subtle and persistent. We created a ghost. An invisible, indelible signature that would forever haunt the winds and waters of our world. A fingerprint of pure energy composed of particles that never existed in nature, which would become the ultimate telltale heart of the atomic age. From that moment forward, humanity would be locked in a desperate search not for new worlds, but for the echoes of its own most dangerous creation. The race to build the bomb was over. The race to hear its silent scream had just begun. The decades that followed were a cold, quiet war fought not on battlefields but in laboratories and listening posts, a global game of chess played with shadows and seismic waves. The world held its breath, suspended in a fragile equilibrium of mutually assured destruction. Trust was a forgotten currency. Verification became the only path to a semblance of peace. But how do you verify a secret? How do you police an agreement when the crime itself, a clandestine nuclear test, could happen half a world away, buried deep within a mountain, or sunk beneath the crushing darkness of the abyssal plain? Challenge was immense to build a planetary nervous system, a network of tireless, impartial sentinels that could feel, hear, and even taste the faintest tremor of a forbidden atomic detonation. It was a monumental undertaking born from the terror of the Cold War, a desperate attempt to give our planet a voice, to make it a witness against our own self-destructive impulses. We had to learn to listen to the Earth itself, to decipher the secret languages it spoke in the shudder of rock, the pulse of water, and the rustle of the very air we breathe. The first language we learned to interpret was the planet's most ancient tongue, the language of stone. Deep beneath our feet, the solid crust of the Earth acts as a colossal bell. Strike it hard enough and it will ring, sending waves of vibration rippling through its mantle for thousands of kilometers. A massive underground nuclear explosion is one of the most violent ways to strike that bell. Seismometers, instruments of exquisite sensitivity once used only to map the natural groans and shifts of tectonic plates, were repurposed. They became the first line of defense, our subterranean watchdogs. Arrays of these seismic stations were meticulously placed across the globe, forming a delicate web to catch the slightest unnatural shudder. But the Earth is a restless, noisy place. It is constantly creaking, groaning, and readjusting itself along ancient fault lines. An earthquake in the Hindu Kush can send a seismic signature that looks to the untrained eye remarkably similar to a 10-kiloton device detonated in a salt dome. The scientists charged with this awesome responsibility became geologic detectives. They had to learn the subtle tells, the unique barometric pressure of an atomic blast that distinguishes it from the sheer grinding release of a tectonic slip. They analyzed the P waves, the primary compression waves that arrive first, and the S waves, the slower shearing secondary waves. A natural earthquake born of rock grinding against rock produces a powerful signature in both. An explosion, however, is a different beast. It is a sudden spherical push outward from a single point, a violent inflation of energy. This creates a massive P wave, but a comparatively weak S wave. That subtle discrepancy buried in a squiggly line on a seismograph became the critical clue. It was the difference between an act of God and an act of man. For decades, these silent guardians in their quiet rooms listened to the whispers in the stone, their work a constant high-stakes interrogation of the planet's deep vibrations, sifting the natural from the nuclear in a relentless search for a hidden truth. But what if the test wasn't buried in rock? What if it was hidden in the one place that covers over 70% of our world's surface, the oceans? The deep sea is a realm of immense pressure and profound silence, a seemingly perfect cloak for a secret detonation. To pierce this aquatic veil, we had to learn the language of the abyss. We deployed hydroacoustic sensors, submerging them deep into the ocean's mysterious heart. These are not simple microphones. They are sophisticated listening devices anchored to the seafloor and tethered to civilization by miles of armored cable. They are tuned to a specific, almost magical property of the ocean, known as the SOFAR channel, or the sound fixing and ranging channel. This is a horizontal layer of water typically found at a depth of around 1,000 meters, where the combination of temperature and pressure creates a unique corridor. Sound waves that enter this channel can become trapped, propagating for immense distances with astonishingly little loss of energy, as if the ocean itself were a planetary-scale fiber-optic cable for sound. An underwater nuclear explosion creates an acoustic shockwave of unimaginable power, a single sharp report that enters this channel and travels not for tens, but for thousands of kilometers. A signal from a test in the remote South Pacific could be clearly heard by sensors off the coast of California. It arrives as a unique acoustic signature, a sudden, violent spike of sound that is utterly alien to the natural chorus of the deep. The scientists listening to this symphony of the abyss had to become masters of marine acoustics. They filtered out the songs of whales, the distant rumble of underwater volcanoes, the grinding of icebergs, and the drone of shipping traffic. They were searching for that one solitary, unnatural sound, the sharp, brutal crack of a fission event echoing through the planet's circulatory system. It was a chilling confirmation that even in the deepest, most crushing blackness of the sea, our most dangerous secrets could not stay hidden. The ocean, too, had been taught to bear witness. There was yet another domain to watch the sky. A large atmospheric nuclear test is not a subtle event. It creates a fireball, a mushroom cloud, a blinding flash of light. But the architects of clandestine tests learn to use cloud cover, remote locations, and the sheer scale of the atmosphere to their advantage. To catch these, we turn to a form of energy that is all around us, yet completely imperceptible to our senses' infrasound. These are sound waves of such a low frequency below 20 Hz that they fall beneath the threshold of human hearing. They are not so much a sound as they are a travelling wave of pressure, a vast, slow-moving ripple in the atmospheric ocean, a volcanic eruption, a massive meteor entering the atmosphere, or a multi-megaton nuclear detonation. All of these events generate powerful infrasound waves that can circle the entire globe multiple times. Specialized microbarometers instruments, capable of detecting minuscule fluctuations in air pressure, were deployed in a global array. They listen for this inaudible roar. The challenge here is separating the signal from the noise. The atmosphere is a chaotic place, a riot of pressure changes driven by weather systems, jet streams, and even distant ocean waves crashing on a shore. Analysts had to develop sophisticated models cross-referencing signals from multiple stations across a continent to triangulate the source of a disturbance. They would look for a specific waveform, a unique pressure signature that screamed explosion rather than storm. By listening to this silent planetary-scale hum, we had effectively turned the sky itself into a tripwire. We had given our atmosphere ears, teaching it to report the inaudible echo of a nuclear fire, a ghost sound from a ghost explosion rippling through the very medium that sustains us, seismic hydroacoustic infrasound. These three pillars formed a powerful system for detecting the times event, times the shockwave, the physical disturbance of a detonation. They could tell you that something had happened, where it happened, and roughly how large it was. But they couldn't offer the one piece of evidence that was beyond all doubt, the irrefutable smoking gun. To get that, we needed to find the bomb itself, or rather the atomic ashes it left behind. We had to learn the fourth and most definitive language of nuclear detection, the language of the atom. We had to learn how to taste the wind. When a nuclear device detonates, it doesn't just release energy, it releases a cloud of new unstable elements called radionuclides. These are the direct physical remnants of the fission process, a swarm of exotic isotopes forged in the heart of the blast. Unlike a shockwave, which is a fleeting event, these particles are physical evidence. They are the fingerprints left at the crime scene, and among the hundreds of different radionuclides created in a fission reaction, one family of isotopes proved to be the ultimate informant, xenon. Xenon is a noble gas. This is a crucial property. It means it is chemically inert. It doesn't react with rock or soil or water. When released into the atmosphere, it doesn't cling to surfaces or get washed out by rain. It simply travels drifting on the global winds for thousands upon thousands of kilometers, like a message in a bottle thrown into a planetary ocean. Detecting these incredibly rare specific isotopes of xenon, like Xenon-135, and most importantly, Xenon-1 135 inches, an air sample is the closest thing we have to absolute proof of a recent nuclear fission event. It is the atomic whisper that confirms all the other rumbles and roars. Finding it is an almost miraculous feat of science, a search for a handful of specific atoms among the quintillions of other particles in every cubic meter of air. It is the final, unassailable piece of the puzzle. This brings us to the human heart of this global machine. In quiet, often windowless rooms scattered in anonymous buildings around the world sit the true guardians of this system. They are not soldiers or spies in the traditional sense. They are physicists, geologists, mathematicians, and data analysts, the high priests of verification. Day after day, they stare at screens displaying the vital signs of an entire planet. They are the interpreters of these esoteric languages. They watch the seismographs for a suspicious tremor from a remote desert. They analyze the hydrophone data for an unnatural crackle from the abyssal depths. They scrutinize the pressure waves for an inaudible atmospheric roar. And they wait for the alerts from the radionuclide stations, the faint electronic chime that signals the capture of a few dozen atoms of a ghost gas. Their work is a unique blend of immense pressure and painstaking patience. A single missed signal, a single misinterpretation, could have staggering geopolitical consequences. They are the anonymous sentinels of the nuclear age, their names unknown, their successes celebrated only in classified reports. They are the human element that makes this technological marvel work, providing the judgment, the intuition, and the cross-correlation that no algorithm can fully replicate. They are the ones who must connect the dots to see that a faint seismic signal from Central Asia, followed hours later by an infrasound ripple detected over Europe, and then days later by a puff of Xenon-135 sniffed by a sensor in our North America, all point back to a single clandestine event. They are planetary detectives piecing together clues written in the languages of physics and chemistry, their investigations spanning continents and oceans. Their sole purpose is to provide an unvarnished objective truth, a ground state reality in a world of spin and speculation. Their work is a silent, unending vigil, a promise that in the atomic age no secret can be kept forever. The planet itself is always watching. And at the absolute apex of this remarkable system, the culmination of 7 decades of science and suspicion, stands a new generation of watchdog. A system so sensitive, it pushes the very boundaries of what is possible. It is known as 3I, Atlas the isotope identification, an atmospheric tracer for advanced surveillance. It is not merely a single instrument, but a distributed intelligence, a network of the most advanced radionuclide detection stations ever conceived. 3I, Atlas, represents the ultimate evolution of our ability to taste the wind. Its sensors are spectral bloodhounds, capable of inhaling vast quantities of air and filtering them with astonishing precision. They can isolate and identify infinitesimal traces of specific isotopes, achieving a level of sensitivity that is almost beyond comprehension. We are talking about detecting parts per quadrillion, the equivalent of finding one specific grain of sand on all the beaches of the entire world. The system is a chronometer for atomic decay. It doesn't just find an isotope like Xenon-135, it measures the precise ratios between different isotopes. Because each radionuclide decays at a known rate, these ratios act as an atomic clock, allowing analysts to calculate times when the fission event that created them occurred, often down to the hour. It is a forensic tool of unparalleled power. 3I, Atlas, is the planet's most sophisticated nostril, a silent, sleepless guardian designed to sniff out the faintest, most fleeting evidence of a nuclear secret. It is the final word, the system that transforms the faintest suspicion into undeniable fact. It represents our most profound commitment to the principle of verification, a technological promise that the ghost of the atom once released will always be found. For years, this system has stood its silent watch, a testament to our deepest fears and our most audacious hopes, performing its vital mission in the background of our lives, until one day, without warning, an alert unlike any other began to cascade through its network. A signal so strange, so powerful, and from a direction so utterly impossible that it would challenge everything we thought we knew. The sentinel that was built to look down at the Earth had detected something from above. The ghost it had finally found was not our own. The signal arrived without fanfare, a silent cascade of numbers appearing on a screen in a darkened room. Yet within minutes, this quiet stream of data had ignited a firestorm that was leaping across continents through encrypted channels. The initial detection was an absurdity, a ghost in the machine so statistically improbable that the first reaction wasn't alarm but disbelief, an error. It had to be a sensor flaw, a cosmic ray striking a delicate circuit, a software bug in the analysis pipeline, because the alternative was unthinkable. Across the global scientific community, the alert spread not as a public announcement but as a series of hushed, urgent phone calls at impossible hours. In Geneva, in Vienna, in Washington, D.C., scientists were pulled from their sleep, their half-finished dinners, their quiet evening lives. They were summoned by coded messages to secure facilities, their minds racing to comprehend the fragment of information they'd been given. Xenon-135, high concentrations, and its orbital trajectory appeared to correlate with the passage of 3I, Atlas. This was the dawn of a frantic clandestine investigation, a race to verify a discovery that threatened to rewrite our understanding of the solar system, or worse, expose a terrestrial secret of terrifying magnitude. The first 24 hours were a crucible of doubt. Every single line of code in the spectral analysis software was meticulously audited. Maintenance logs for the specific telescopic array that caught the initial reading were pulled, scrutinized for any hint of anomaly, any recent repair or recalibration that might have introduced a phantom signal. You see, in the world of high-energy physics and remote sensing, the universe is a noisy place. Our planet is constantly bathed in a shower of particles from the sun and deep space, a form of cosmic static that can mimic all sorts of phenomena. Scientists spend their entire careers learning to distinguish the signal from this noise, to find the one true note in a cosmic cacophony. This reading was so clean, so potent, it felt like a trap. It was too perfect. The team that made the initial discovery was placed under an effective quarantine of information their data impounded, as other independent teams were tasked with the most crucial job in modern science replication. They couldn't be told what they were looking for, not precisely. To do so would be to introduce confirmation bias, the enemy of objective truth. Instead, other observatories with similar spectroscopic capabilities were given a cryptic directive: re-examine all archived sensor data from a specific window of time in a specific quadrant of the sky and search for any isotopic irregularities. The wait was agonizing. For the original team, it was a period of intense self-doubt, replaying every step, every calculation, haunted by the fear that a simple mistake was about to cause an international incident. They were like cartographers who had discovered a new continent on an old map, terrified that it was merely a smudge of ink. Then the first confirmation came in. A radio telescope consortium in Chile, running their analysis on a completely different software platform, found it. The same spectral line, the same impossibly high reading of Xenon-135, a radioactive noble gas with an infamous and very specific parentage. A few hours later, a third signal arrived from a high-altitude observatory in the Himalayas. The smudge of ink was real. The continent existed. The disbelief that had initially insulated them from the terrifying implications now evaporated, replaced by a cold professional dread. This was no longer a potential error. It was a verified phenomenon. The nature of the investigation immediately pivoted. With the signal's existence confirmed, the question became not times, if times, but times from where, asterisk. The focus shifted from the astronomers to a different, far more secretive community, the global network of radionuclide monitoring stations. These are the silent sentinels of our planet, the watchdogs of the Comprehensive Nuclear Test Ban Treaty. Operated by the CTBTO in Vienna, this network of over 80 stations is designed to do one thing with breathtaking precision: sniff the air. They are the planet's nervous system, constantly tasting the wind for the faintest trace of radioactive isotopes that would betray a nuclear explosion anywhere on Earth. Their sensors are so sensitive they can detect the minuscule radioactive signature from medical isotope production thousands of miles away. If a nuclear event had happened on our world, they would know. Secure communiques stripped of all but the most essential data were dispatched to the CTBTO's International Data Center. The request was unprecedented. They weren't being asked to look for the fallout from a terrestrial blast, but to search their atmospheric data for a signature that appeared to have an extraterrestrial origin point. Could their ground-based stations detect a plume of radioactive gas that had rained down from the upper atmosphere? The computers in Vienna began their work cross-referencing petabytes of data from stations scattered across the globe, from the desolate ice of Antarctica to remote islands in the Pacific. They were performing a forensic autopsy on the very air we breathe. Simultaneously, another set of doors was opening, doors that rarely open to the civilian scientific world. National intelligence services, with their own constellations of clandestine satellites and over-the-horizon sensor networks, were quietly looped in. In Langley and Cheltenham, analysts who normally track troop movements and terrorist communications were now being briefed by shell-shocked physicists. They brought a different perspective, one steeped in suspicion and the grim realities of geopolitics. Their first question wasn't about the science, it was about deception. Could this celestial event be a cover? A sophisticated, brilliantly orchestrated feint designed to mask a clandestine nuclear test on Earth? Could a rogue state have timed a secret detonation to coincide with the comet's passage, hoping the bizarre astronomical data would confuse and distract the Deely international community? The very idea sent a chill through the investigation. It fractured the problem into two distinct, terrifying possibilities, each with its own set of earth-shattering consequences. The first path led to the stars, to the mind-bending reality that we had just witnessed, an event around 3I, Atlas, for which we had no explanation. The second path led back to Earth, to the brink of a global security crisis. To solve this, scientists had to become detectives on a planetary scale. They needed to trace the Xenon-135 back to its source, a process called atmospheric transport modeling. Imagine releasing a single drop of red dye into a vast, turbulent ocean. Now, imagine trying to figure out, days later, and thousands of miles away, exactly where that drop entered the water. That is the challenge they faced. Xenon-135 is a gas. Once released into the atmosphere, it doesn't stay put. It is captured by the wind, whipped into the relentless currents of the jet stream, and smeared across entire hemispheres like a watercolor paint stroke. Its half-life is brutally short, just over 9 hours, meaning it decays into stable, non-radioactive isotopes with relentless speed. The investigators were not just chasing a ghost, they were chasing a ghost with a stopwatch. At supercomputing centers around the world, sophisticated models of the Earth's atmosphere were spun up. These are digital twins of our planet, stunningly complex simulations that account for every variable: wind speed, temperature, gradients, atmospheric pressure, humidity, even the influence of mountain ranges on air currents. They are the same models used to predict the path of a hurricane or the spread of volcanic ash. Now they were being repurposed for a nuclear manhunt. Scientists fed the location and concentration data from the CTBTO's global network into the simulations. Then they ran the models backward in time. The goal was to reverse the flow of the invisible rivers in our sky, to rewind the journey of these radioactive atoms and force the models to converge on a single point of origin, a geographical ground zero. The early runs were a mess of contradictions. Some models, factoring in the high-altitude readings, pointed to a release point somewhere over the North Pacific. Others, giving more weight to a cluster of faint detections in northern Europe, suggested a source deep within the Eurasian continent. The data was sparse, the signal-to-noise ratio was a nightmare, and the short half-life meant the trail of evidence was literally vanishing with every passing hour. The pressure inside these research centers was becoming unbearable. Teams worked in shifts around the clock, fueled by caffeine and adrenaline, their faces illuminated by the glow of cascading simulations. They argued over which model was more reliable, which data points were likely to be outliers, and which atmospheric assumptions were the most sound. Every decision was fraught with immense weight because they knew the world's leaders were waiting for an answer, and pointing a finger at the wrong place at the wrong nation could be catastrophic. While the atmospheric modelers chased the plume, another group of specialists was engaged in a different kind of forensic analysis. They were scrutinizing the isotopic fingerprint of the detection itself, because not all nuclear events are created equal. A modern nuclear weapon and a civilian nuclear reactor are like two different kinds of engines. They both run on nuclear fission, but they produce a different cocktail of exhaust fumes. A weapon's detonation is an instantaneous, uncontrolled chain reaction. It produces a very specific ratio of radioactive isotopes, a signature as unique as a fingerprint. You get a blast of Xenon-135, yes, but you also expect to see other telltale products like barium-140 and iodine-131 inches predictable amounts. A nuclear reactor, on the other hand, is a slow, controlled fission event. It produces vast quantities of xenon, especially if there's a problem, but its isotopic cocktail is different. It would be like comparing the smoke from a log fire to the exhaust from a diesel engine. Both are smoke, but a chemical analysis can easily tell them apart. So the second great race began, the search for companion isotopes. If this was a bomb, where were the other elements that should have been born in the same flash of light? If this was a reactor meltdown, why hadn't any nation declared an emergency? The International Atomic Energy Agency was making discrete, high-priority inquiries with every nation operating nuclear power plants. Each response came back negative. All reactors were reported as stable. All safety systems were green. The silence was deafening. This deepened the mystery and fed the paranoia of the intelligence agencies. If it wasn't a declared accident, then it had to be a clandestine one. A secret military reactor hidden from international inspectors suffering a catastrophic failure. Or worse, a new type of weapon, one that produced a cleaner isotopic signature deliberately designed to sow confusion and evade detection protocols. The theories were flying thick and fast, each more unsettling than the last. Days turned into a week. The initial frantic sprint had turned into a grueling marathon. The world oblivious went about its business. People looked up at the night sky, perhaps catching a glimpse of the faint smudge of 3I. Atlas seeing it as a beautiful, silent wanderer. They had no idea it had become the focal point of a global crisis, a celestial suspect in the most high-stakes investigation on Earth. For the scientists and analysts at the heart of the storm, the lack of a clear answer was maddening. They had confirmed the impossible. A cloud of freshly produced radioactive material was present in our atmosphere. They had ruled out sensor error and every conceivable natural phenomenon. They had two plausible but terrifying origin stories, a secret nuclear bomb or a secret reactor meltdown, yet the evidence refused to fully support either one. The isotopic ratios were wrong for a classic weapon. The sheer amount of Xenon-135 seemed too high for a conventional reactor accident, and no nation was raising the alarm. The atmospheric models, after a week of refinement and countless processing hours, were beginning to converge, but on something that made no sense. They weren't pointing to a single fixed location on the Earth's surface. The backtracking analysis didn't resolve to a neat point in some remote desert or an undisclosed industrial complex. Instead, the models kept pointing upwards. They indicated a massive instantaneous release of material not at ground level but in the upper stratosphere, across a vast and diffuse area. It was a release profile that didn't match any known terrestrial event. It was as if the material had been painted across the top of the atmosphere by a giant brush. This was the moment the two parallel investigations, the astronomical and the terrestrial, finally and terrifyingly collided. The intelligence agencies searching for a secret bomb on the ground found nothing. The nuclear regulators searching for a failing reactor found only silence. And the atmospheric scientists searching for a ground zero found their models pointing back to the sky, back towards the very trajectory from which the first anomalous signal had come, back to 3I, Atlas. They had exhausted every earthly explanation. They had chased every shadow, questioned every assumption, and followed every lead back to a dead end. And in doing so, they were forced to turn their gaze away from the familiar fears of human conflict and technological failure. They had to confront the chilling possibility that the source of this nuclear signature was not from our world at all. The frantic search for a human culprit had cleared the stage, leaving only the original impossible suspect, an interstellar visitor now seeding our planet with the unambiguous fingerprint of nuclear fission. The investigation was no longer about who, it was about what. For weeks the ghost had haunted us. A phantom born of fission, its ephemeral radioactive breath had touched the most sensitive instruments we had ever built, yet it left no other trace. The atmospheric models, the pride of global meteorology, had become instruments of frustration. They were designed to predict the weather, to chart the course of hurricanes, and the flow of jet streams with exquisite precision. But this was different. This was not a storm front. This was a whisper, a trace element carried on the chaotic, unpredictable currents of the planet's own breath, a single radioactive needle lost in a haystack the size of a world. Every simulation we ran ended in a fog of uncertainty. The back trajectories, the complex algorithms meant to rewind the winds and trace the plume to its source, would diverge into a meaningless smear of possibilities. The answer could be anywhere, and therefore it was nowhere. The data screamed that a nuclear event had happened, but the physics of the sky stubbornly refused to confess where. This impasse was more than a scientific puzzle. It was a geostrategic nightmare. In quiet, secured rooms from Washington to Beijing, the same impossible maps were projected onto screens, a crimson stain of probability that covered half a hemisphere. Was it a reactor leak a nation was desperately trying to conceal, a covert weapons test that had gone wrong, a state actor brazenly violating every treaty we held dear? Or was it something else entirely, something so far outside our understanding of nuclear physics that we lacked the framework to even ask the right questions? The silence from the world's governments was deafening, a collective holding of breath. no one claimed responsibility, no one pointed a finger. Because to point a finger was to risk being wrong, to risk igniting a conflict over a ghost. The world was on a knife's edge, balanced on the point of a single unlocatable atom of Xenon-135. This stalemate was untenable. The search had to evolve, or the mystery would fester into a permanent low-level terror, a constant nagging reminder that our control over the atom was perhaps an illusion. The breakthrough didn't arrive like a thunderclap. It began in the hushed, humming server rooms of the Comprehensive Nuclear Test Ban Treaty Organization in Vienna and in the distributed computing networks of climate science centers across the globe. For years, a new generation of atmospheric modeling had been quietly under development, a system so complex, so computationally hungry it was considered almost theoretical. They called it Heliosphere Earth Interaction Code, or HEIMDOL. Unlike its predecessors, which treated the atmosphere as a self-contained system, HEIMDAL was built on a radical premise that our planet's air does not merely churn, it breathes in rhythm with the sun. It was designed to model not just wind, but the impossibly subtle pressures exerted by the solar wind, the way our planet's magnetic field flexes and warps, funneling charged particles into the upper atmosphere. It factored in the faint ionization trails left by meteoroids burning up 80 kilometers above our heads, and the almost imperceptible atmospheric tides pulled by the moon. To the meteorologists of the old school, it was computational overkill, a digital sledgehammer to crack a nut. But for the Xenon problem, it was the key. The plume wasn't just times in times the atmosphere, it was interacting with it at a quantum level. Its atoms were being ionized by cosmic rays, nudged by geomagnetic storms, and subtly sorted by stratospheric temperature gradients that older models had rounded off into irrelevance. Running HEIMDOL was like trying to create a perfect digital twin of Earth's entire atmospheric column, from the sea spray at the surface to the last tenuous molecules bleeding into the vacuum of space. The demand for processing power was gargantuan. A global consortium of supercomputers was linked together, a planetary-scale brain dedicated to a single task. For 72 continuous hours, machines that normally simulated galaxy formation or protein folding were enslaved to this one problem. They ingested every scrap of data the International Monitoring System had gathered, every faint puff of xenon detected from the Arctic Circle to the South Pacific. Then they began to run time backward. On the central monitors in Vienna, we watched the simulation unfold. It was not a simple rewind. It was a digital seance. Billions of virtual xenon particles were released in the model, their paths calculated against a torrent of real-world data. We saw the solar flare that had erupted 2 days before the first detection, and watched as Heimdall calculated how its wave of protons had fractionally altered air pressure over the North Atlantic. We saw the model account for a sudden stratospheric warming event over Siberia, an atmospheric anomaly that had acted like a temporary wall deflecting a portion of the plume southward. These were the ghost currents, the invisible forces that had smeared the trail and confounded all previous efforts. The model was no longer just mapping the wind, it was mapping the physics of the entire planet. It was an act of computational brute force that bordered on artistry, a machine dreaming the journey of a single invisible cloud. The fog of uncertainty on the global map began to thin. The continent-sized smears of probability started to shrink, pulled into focus by the gravity of a million new data points. The ghost was beginning to acquire a shadow, but even this revolutionary model was only half of the equation. A perfect simulation is useless if you don't feed it perfect, or at least profoundly comprehensive data. The second part of the breakthrough came from a team of data scientists who decided to look far beyond the traditional radiological sensor network. Their hypothesis was simple yet audacious. A nuclear event of this magnitude, whatever its nature, could not happen in a vacuum. It must have left other fingerprints faint and scattered on the global sensor network. They began a process they called multi-domain data fusion, a high-tech dragnet for anomalies. They started with infrasound. The same network used to listen for volcanic eruptions or meteor impacts might have heard something, a low-frequency hum, just at the edge of perception from the moment of the Xenon's release. They correlated petabytes of infrasound data with the new atmospheric model, asking the machine to listen for a whisper that had come from the same place at the same time as the plume's origin. The system found nothing, a dead end. Undeterred, they moved to seismic data. A clandestine explosion, even a deeply buried one, should send a shiver through the planet's crust. They cross-referenced the world's most sensitive seismographs, instruments capable of detecting a truck driving on a highway from 100 kilometers away. They searched for a tremor, however small, that could be the Rosetta Stone event, the physical concussion that matched the timing of the atmospheric release. Again, the result was a chilling, profound silence. The Earth had not shuddered. This was not a bomb test in the conventional sense. The mystery deepened. The event had been powerful enough to generate a detectable plume thousands of kilometers away, yet it had been seismically and acoustically invisible. This paradox was terrifying. It suggested a type of release that defied our established categories. It wasn't a classic underground test, and it wasn't a Chernobyl-style atmospheric breach. It was something new. The team then made an inspired, almost desperate leap. They began pulling in data that seemed on the surface to be completely unrelated. They looked at the global network of GPS satellites, whose timing signals are so precise they can be minutely distorted by changes in atmospheric ionization. A large release of radioactive isotopes would theoretically create a temporary bubble of charged particles, a fleeting scar in the ionosphere. They scoured the timing logs for a synchronized multi-satellite anomaly. They pulled thermal data from weather satellites, looking for a momentary inexplicable hotspot on the Earth's surface, a pinpoint of heat that had no geological or meteorological cause. They even ingested data from the worldwide lightning detection network on the wild theory that the release could have generated a unique electromagnetic pulse. They were no longer just looking for a nuclear signature. They were looking for any ripple, any perturbation in the entire technological nervous system we have wrapped around our planet. They were feeding the beast HEIM doll with every scrap of information they could find, turning it from a weather model into a planetary detective. And that is when it happened. An analyst staring at a feed from a European Space Agency satellite noticed the flag. It wasn't from the primary imaging sensor. It was a secondary instrument, a spectrometer designed to measure trace gases, methane, carbon dioxide, sulfur dioxide for climate change research. The instrument had registered a bizarre off-the-charts reading, not of xenon, which it was never designed to see, but of its decay products. Short-lived isotopes of iodine and cesium particles with half-lives so brief they would have been undetectable by the time the plume reached the ground-based IMS stations. They existed for only a few hours, a fleeting radioactive afterimage in the upper atmosphere. This satellite had by sheer chance passed directly over the plume just moments after its birth. It was the smoking gun. This new data, this spectral fingerprint of the plume in its infancy, was the missing piece. It was the gravitational anchor the HEIM doll simulation had been searching for. The team fed the spectral data into the running simulation. On the main screen in Vienna, the effect was instantaneous and breathtaking. It was like a lens snapping into focus. The shrinking but still vast area of probability collapsed. It was a cascade of certainty. The crimson stain on the map, which had covered half of Asia and Eastern Europe, vanished. In its place, a single incandescent pixel began to burn. The convergence was absolute. The model's billion virtual particles traced back through the ghost currents, and the solar winds all arrived at this one point on the globe. There was no ambiguity, no statistical noise. The probability was over 99%. The ghost had a home. For a full minute, no one in the control room spoke. They just stared at the screen at the coordinates that had just appeared. They were staring at a location so unexpected, so deeply wrong, it felt like a glitch in the system. The machine had to be mistaken. They ran the simulation again and again. Each time the result was the same, an unblinking, terrifying certainty. The source of the most significant nuclear event of the 21st century was not in the sprawling weapons complexes of a superpower. It was not at a known nuclear reactor site. It was not in the rogue states we watched with such unceasing vigilance. The coordinates pointed to a featureless, uninhabited stretch of the Southern Ocean, thousands of kilometers from any landmass. A place known to sailors and scientists as Point Nemo, the oceanic pole of inaccessibility. the most remote location on the face of the Earth. It is the place where old satellites and space stations are deliberately deorbited to die a spacecraft cemetery at the bottom of the world. It is by definition the place on this planet farthest from human civilization. And yet from this desolate void, a plume of Xenon-135 had risen, a material that can only be created by humans through the deliberate act of splitting an atom. The silence in the room was finally broken by a single whispered question that would come to define the next stage of the crisis. What is times out there times the revelation sent a shockwave through the very foundation of our understanding of nuclear security. The carefully constructed edifice of international monitoring of treaties and non-proliferation was built on the assumption that nuclear activities happen in specific, identifiable places. They require infrastructure. They require land. They require a nation-state. This broke every rule. An event with the signature of a sophisticated nuclear process had occurred in a place with nothing. No land, no facilities, no people. The implications were dizzying. Did a nuclear-powered vessel, perhaps a submarine, suffer a catastrophic accident, and a government was somehow managing the most successful cover-up in human history? The lack of seismic or infrasound signals seemed to argue against a violent explosion. Had someone intentionally vented radioactive material in the most remote place possible, thinking it would never be traced? If so, why? Was it a test of a new kind of weapon, a radiological device designed for pure contamination? Or, and this was, the thought that kept everyone awake in the nights that followed, was it something we had put there ourselves? In the frantic search that began, researchers pored over the logs of every object ever deorbited over Point Nemo. They were looking for anything containing a nuclear power source, a radioisotope thermoelectric generator or RTG of the kind used to power deep space probes. Could one of these, an object we ourselves had consigned to a watery grave, have somehow undergone a spontaneous uncommanded fission event on the seafloor? The physics seemed impossible, a 1 in a trillion chance. But the alternative, that a human actor had built a secret sea-based nuclear capability and deployed it in total secrecy, was almost too terrifying to contemplate. The narrative had irrevocably shifted. The global search for a needle in a haystack was over. Now began something far more frightening, a focused, direct confrontation with an impossibility. We knew where the ghost had been born. Now we had to sail into the heart of the world's most desolate ocean, to the loneliest place on Earth, and find out what kind of machine, what kind of power, what new and terrible kind of threat was waiting for us in the crushing, silent darkness of the abyss. For 72 terrifying hours, that knowledge existed only as encrypted bits on a handful of secure servers, a secret that burned with the intensity of a star. The coordinates, once a mere astronomical curiosity, had become the most dangerous piece of information on Earth. Within the highest echelons of power, a shockwave of silence spread faster than any news bulletin ever could. Leaders who had spent their careers navigating the predictable terrain of terrestrial conflict were suddenly confronted with a message from the void that spoke their own terrible language of fission. The confirmation of Xenon-135, that unambiguous spectral ghost of a nuclear event, had transformed the 3I Atlas Observatory from a scientific instrument into a planetary nerve ending, one that had just been touched by an incomprehensible fire. In those first hours, the protocols of science gave way to the instincts of national security. The initial calls were not to astronomers, but to generals and intelligence chiefs. You can imagine the scene: hushed voices on encrypted lines, faces illuminated only by the glow of screens displaying the damning data. The graphs and charts, which to a scientist represented a beautiful puzzle, now looked like the preliminary damage report from an attack nobody knew how to classify. The first question was not what is it, but whose is it? A frantic, silent inventory was taken within every nuclear-capable nation. Was it a clandestine weapons test, gone horrifically wrong? A secret space-based platform that had suffered a catastrophic failure? Fingers were pointed in the darkness, old suspicions resurfacing with venomous speed. Every nation's denial was met with a chilling counter-question. If not you, then who? But a secret of this magnitude has its own gravitational pull, its own inescapable event horizon. It cannot be contained by classification stamps or threats of treason. It began as a tremor in the deep web, a cryptic data packet shared between astrophysicists who knew the official story was a lie. The initial public report from the Atlas Consortium was a masterpiece of scientific evasion, speaking of anomalous isotopic readings and unusual energy signatures. To the layman, it was jargon. To those who knew what to look for, it was a coded scream. The word xenon was the key. Once that single word leaked from a university server in Germany and was cross-referenced with the public astronomical logs by an amateur observer in Japan, the dam broke. The ensuing cascade of global anxiety was biblical in its scale. It was a crisis that fell quite literally from the heavens. News anchors who a week before had been debating economic policy now struggled to explain nuclear decay chains to a terrified public. The world learned a new horrific vocabulary overnight. Isotopes, half-life fission products. Xenon-135 became an incantation of dread, a name whispered in homes from Seoul to Sao Paulo. The footage of the observatory, once a symbol of human curiosity, was now replayed endlessly, its silent, gleaming dome looking like an unblinking eye that had witnessed some cosmic atrocity. Panic is an emotion that needs a target, a face. But the source was a cold, indifferent set of coordinates in the sky, an enemy we couldn't see, couldn't understand, and couldn't fight. This abstract nature of the threat only amplified the fear, turning it into a low-frequency hum of existential dread that vibrated beneath the surface of modern life. In the corridors of the United Nations, a new kind of Cold War began, a war of frantic, uncertain diplomacy. The Security Council convened in a permanent, fraught session, the chamber thick with a mixture of accusation and genuine bewilderment. The old geopolitical chessboard was overturned. This wasn't about borders or resources. It was about a violation of a fundamental, unspoken rule the chaos of Earth was meant to stay on Earth. The question of origin became the fulcrum of this new global conflict, splintering into three terrifying and mutually exclusive possibilities, each with its own devastating implications. The first and most horrifying was that of a deliberate act. Had some terrestrial power achieved a level of stealth space technology far beyond public knowledge? Was this the test of a new orbital weapon system, a shot across the bow in a war we didn't even know had started? Military analysts worked feverishly, trying to model the energy release to reverse engineer the technology from its nuclear ghost. The signature was clean, almost too clean, suggesting a highly advanced device, not a crude, messy explosion. This hypothesis pointed toward a state actor of immense sophistication, one capable of launching and operating a nuclear reactor in deep space with perfect secrecy. The implications were earth-shattering. It meant that one nation held a decisive, terrifying advantage, a sword of Damocles hanging not just over its rivals, but over the entire planet. The paranoia was palpable. Every satellite launch, every military exercise was re-examined, scrutinized for any hint of its connection to the event. The second possibility was in some ways almost as frightening an unprecedented technological failure. Perhaps this wasn't a weapon at all, but a next-generation propulsion system. For decades, engineers had dreamed of nuclear-powered spacecraft capable of traversing the solar system in months, not years. Fission fragment rockets, nuclear pulse propulsion. The theoretical designs existed, promising a new golden age of exploration. Had someone secretly built such a craft? Had a prototype operating far from prying eyes suffered a containment breach? This scenario painted a picture not of malice, but of hubris. It suggested a power that had reached for the stars but had stumbled catastrophically. The Xenon wasn't an attack. It was a tombstone, an SOS, that arrived as an obituary, yet this brought little comfort. What kind of organization, public or private, could develop such technology in total secrecy? And more importantly, if they had lost control of one such device, were there others? Was the solar system now seeded with silent radioactive time, bombs waiting to fail? Then there was the third door, the one nobody wanted to open. The possibility that the source was not human at all. This was the theory whispered by exhausted scientists in the dead of night, after the politicians and generals had gone home. The Xenon-135 signature, while identical to our own fission products, was just a data point. It was an arrangement of atoms. We interpreted it as nuclear because that is the only frame of reference we possess. Could it be something else entirely? A natural but previously unobserved astrophysical phenomenon, a form of stellar decay in a hyperdense object that just happened to mimic the atomic language of our bombs? Or, and this was the true abyss, was it the byproduct of a technology so alien that we were misinterpreting its industrial exhaust as a weapon's signature? We were like a tribe of ancient humans finding a modern circuit board on the forest floor. Concluding its intricate lines must be a form of insect trail, unable to even conceive of silicon or electricity. This hypothesis offered no comfort, only a profound sense of cosmic vertigo. It meant we weren't just facing a threat, we were facing the utter demolition of our understanding of the universe. Caught in the crossfire of these terrifying debates were the scientists themselves. The very people who had made the discovery were now thrust into a crucible of ethical and political pressure. They were summoned to clandestine briefings, their labs placed under military guard. Their work, once a pure pursuit of knowledge, was now intelligence, a vital national security asset. And they were being asked for something they could not possibly provide certainty. A general wants a yes or no. A president needs to know who to blame. But science doesn't work that way. It works in probabilities, in confidence levels, in margins of error. When a physicist said there was a 99.9% certainty that the isotope was Xenon-135, the politician only heard the 0.1% of doubt, a chasm wide enough to drive a war through. They faced a terrible dilemma. If they emphasized the deliberate act hypothesis, their words could be twisted into a justification for preemptive war. If they leaned toward technological failure, it could trigger a global panic about radioactive debris and collapsing space infrastructure. And if they dared to voice the unknown or alien hypothesis, they risked being dismissed as fantasists, their credibility shredded at the moment it was most needed. They were being asked to translate the nuanced language of spectral analysis into the brutal binary code of geopolitics. Every public statement was scrutinized, every interview passed for hidden meaning. They became unwilling prophets, their data a new and terrible scripture from which the world desperately sought meaning. Their scientific integrity was in direct conflict with the urgent primal need for a simple answer. This pressure was compounded by the immense technical challenge of verifying the intelligence. The discovery was, for now, a ghost. A single detection from a single observatory complex, no matter how advanced. To be certain, the signal needed to be corroborated. A global high-stakes scientific manhunt began. Radio telescopes across the world swiveled in unison, slewing their massive dishes toward that one patch of empty-looking sky, straining to hear the faintest whisper of an echo. Neutrino detectors buried deep in Antarctic ice, and beneath Japanese mountains, sifted through trillions of passing particles, hoping to catch a stray ghost particle born from the event. Gravitational wave observatories, the most sensitive listening posts ever built by humanity, analyzed their data streams for the faintest tremor in spacetime, a ripple from the distant violent fission. The challenge was monumental. The source was moving, receding from us at thousands of kilometers per second. Its signal was Doppler shifted, stretched and distorted by the vast and expanding emptiness between us. Scientists had to model this shift with painstaking precision, creating a key to unlock the signal from the background noise of the cosmos. It was like trying to hear a single specific whisper in the middle of a hurricane. Furthermore, they had to definitively rule out every conceivable terrestrial or solar system origin. Could a previously unknown cloud of gas in our own Oort cloud have somehow mimicked the signature? Could the observatory's own sensitive electronics have created a phantom in the machine? Every aspect of the Atlas system was disassembled, tested, and recalibrated. Teams from rival nations were invited to inspect the hardware and the software, an unprecedented act of scientific transparency born of sheer desperation. Nobody could afford for this to be a mistake. While the scientists hunted for corroboration, the diplomats fought to prevent the crisis from spiraling into open conflict. The initial unity of fear quickly fractured along old fault lines. In Beijing and Moscow, the event was framed as a potential failure of Western space technology, a sign of its reckless ambition. In Washington and Brussels, it was seen as a possible secret test by a resurgent rival, a challenge to the established order. The rhetoric grew hotter, more dangerous. Embassies issued formal protests based on nothing more than speculation. Military forces were placed on higher alert, not because of an impending attack, but because of the sheer unbearable tension of the unknown. The event acted as a catalyst, pouring gasoline on the smouldering embers of every international dispute. The crisis revealed a terrifying vulnerability we had never considered. Our entire global security infrastructure, our trillions of dollars of military hardware and intelligence networks were designed to watch each other. We had spent a century perfecting the art of looking across borders, across oceans. We never ever thought we would have to look up. Now we found ourselves utterly unprepared, armed with tools for a game whose rules had been completely rewritten without our consent. The systems designed to prevent nuclear war were themselves threatening to cause one, as the logic of mutual assured destruction began to crumble when you didn't know who to assure or what to destroy. We were standing on a precipice, a species united in fear but divided by instinct. The scientific quest for truth had become inextricably tangled with the political demand for a culprit. And as teams of analysts continued to sift through the petabytes of data from the Atlas follow-up observations, they began to notice something else. It was subtle, buried deep within the noise of the Xenon signature. A secondary signal, a faint and impossibly regular pulse, hidden beneath the chaotic decay of the primary event. It was not a natural frequency. It was structured, patterned, complex. It was a signal within the signal. The nuclear ghost wasn't just a tombstone or an echo of a weapon. It was a carrier wave, and something, or someone, was still broadcasting. The spectral signature of Xenon-135 was no longer just a ghost. It was a poltergeist rattling the very foundations of our understanding of global nuclear activity. In the hushed, pressurized confines of the 3I, Atlas Data Fusion Center, the initial shock had sublimated into a cold, diamond-hard resolve. The team, a global consortium of the planet's sharpest minds, understood that identifying the presence of this ephemeral isotope was merely the opening chapter of a terrifying mystery. The real work, the painstaking and potentially world-altering work, was just beginning. It was one thing to hear a scream in the dark. It was another entirely to find its source, to understand the nature of the beast that uttered it, and to count the bodies it left in its wake. This next phase of the investigation would not be a single elegant breakthrough. It would be a grinding, relentless forensic campaign fought on 3 fronts in the ephemeral world of atomic decay, in the chaotic maelstrom of planetary weather, and in the shadowy realm of closely guarded intelligence. The first front was the deep, intricate world of the radionuclides themselves. Xenon-135 was the headline, the stark, screaming announcement of a nuclear fission event, but it was a notoriously unreliable narrator on its own. Its short half-life of just over 9 hours meant it was a fleeting witness, one that pointed to a recent event but offered few details. To build a complete picture, the team needed its accomplices, the other isotopes, inevitably forged in the same atomic crucible. They began a process akin to atomic archaeology, sifting through the terabytes of atmospheric data for the fainter but more informative spectral echoes of other fission products. They were searching for the event's complete isotopic fingerprint, a unique combination of elements that could tell them not just times a nuclear chain reaction had occurred, but precisely times how asterisk. Soon they found the first ghost, iodine-131. With a half-life of 8 days, iodine-131 is the classic telltale of a recent reactor incident or detonation. Its presence in the specific ratios they were detecting confirmed that the fission event was not just recent, but extremely fresh, a matter of days, not weeks. This single discovery dramatically narrowed the timeline, transforming a vague period of uncertainty into a ticking clock. The event had happened within the last 100 hours. This was no cold case. The crime scene was still warm. Then came another crucial character in this atomic drama, barium-140. Its relationship to its daughter isotope lanthanum-140 acts as a precise atomic stopwatch. By measuring the ratio between the two, physicists can calculate with astonishing accuracy the exact time that has elapsed since the moment of fission. The team ran the calculations again and again, their results converging on a horrifyingly narrow window. The stopwatch had been started just 79 hours ago. But what kind of fission? Was it the controlled, sustained reaction of a power plant, or the violent, instantaneous fury of a weapon? The answer lay in the heavier, more sluggish isotopes, the ones that linger in the environment for years even, centuries. They hunted for traces of cesium-137 and strontium-90. While a nuclear weapon's flash-fired explosion creates a very specific high-yield ratio of these elements, a reactor core which has been cooking for months or years produces a vastly different signature, rich with a whole menagerie of fission byproducts. The data that trickled in was baffling. It fit neither profile perfectly. There were telltale signatures of a sustained reaction suggesting a reactor source, yet the sheer concentration of certain short-lived isotopes like the xenon itself hinted at a power excursion of unimaginable violence, a flash of criticality far beyond any conventional meltdown scenario. It was a paradox, a Frankenstein's monster of an isotopic signature that had no precedent in the annals of nuclear science. It was as if a power plant had for a fraction of a second detonated. This perplexing fingerprint was the first key, but it gave them no sense of geography. For that, the investigation had to move to its second front, the war against chaos itself, the attempt to map the journey of the plume. They turned to the world's most powerful supercomputers machines, tasked with running advanced atmospheric dispersion models. You have to understand this is not like tracking a simple dust cloud. You are tracking an invisible river of gas, a spectre flowing through the planet's circulatory system. This river is twisted and torn apart by 1,000 different forces. The team had to build a four-dimensional map of the atmosphere, a digital ghost of the Earth's weather systems as they existed over the past 80 hours. They fed the models every scrap of data they could find: real-time wind speed and direction from thousands of weather stations, atmospheric pressure gradients from commercial airliners, temperature and humidity readings from high-altitude balloons. They factored in the planet's own spin, the subtle but powerful influence of the Coriolis effect that sends weather systems spiraling across continents. They modeled thermal inversions, those invisible atmospheric lids that can trap pollutants close to the ground, and the powerful high-altitude jet streams that can whisk them across oceans in a matter of days. The computers churned for hours, then for a full day, processing petabytes of information. They were attempting to reverse time, to rewind the chaotic dance of the wind, to force the plume back from its dispersed ethereal state into a single cohesive point of origin. The first results were a crushing disappointment. The models produced not a single point, but a vast smeared arc of possibility, a so-called threat vector that stretched for over 3,000 kilometers, curving from the desolate plateaus of Central Asia across the rugged mountain ranges of the Caucasus and ending ominously in the densely populated heart of Eastern Europe. The source could be anywhere along that line. For the exhausted scientists, it felt like a monumental failure. They had the killer's DNA, but the list of suspects included 3 entire continents. The problem was a lack of data points. They had detected the plume over Scandinavia and parts of the Arctic, but that was only one slice of a much larger picture. They needed more sensors, more eyes on the sky to triangulate the source. This is where the true power of the 3i Atlas network came into play. It was more than a single observatory. It was a global nervous system. An urgent encrypted request went out to every partner station from Japan to Canada, from Argentina to South Africa. Reanalyze all atmospheric radionuclide data from the past 5 days, no matter how insignificant the reading. Within hours, the floodgates opened. A station in Alaska reported a faint, almost subliminal spike in iodine-131 that had initially been dismissed as sensor noise. Another high in the Italian Alps found a whisper of barium-140. Each new data point was another pin in the map, another anchor to constrain the wild projections of the dispersion models. With this new, richer dataset, they ran the simulations again. The team watched in silence as the great sweeping arc of uncertainty began to shrink. The new data points acted as gravitational anchors, pulling the chaotic projections into line. The vast smear collapsed, contracting hour by hour, as the models refined their calculations. The 3,000-kilometer line of inquiry shrank to 1,000, then to 500. Finally, after 36 hours of continuous processing, the models converged. They produced a tight, terrifyingly small circle, a probability box just 50 kilometers in diameter. It was centered on a bleak, unforgiving stretch of land in the northern Ural Mountains, a region shrouded in military secrecy since the dawn of the Cold War. A place officially designated as a closed administrative territorial formation, a ghost on most public maps. They had a location. Now the third front of the investigation opened, moving from open science to the clandestine world of national intelligence. The coordinates of the probability box were securely transmitted to partner agencies whose own powerful assets could be brought to bear. The request was simple: show us what is inside that box. What happened there approximately 85 hours ago? The first layer of evidence came from the sky. Analysts began spooling through high-resolution satellite imagery, both optical and synthetic aperture radar, which can see through cloud cover. They compared images from a week ago with those taken in the last few days. At first, nothing. The landscape was a monotonous tapestry of snow-dusted forest and bleak rocky outcrops. But one sharp-eyed analyst at the United States National Reconnaissance Office spotted it. An anomaly. It wasn't a crater or a scorch mark. It was far more subtle. In the before image, a small frozen lake near the center of the box was a uniform sheet of white. In the after image taken just yesterday, the lake was completely free of ice, its dark water steaming into the frigid air, a massive, inexplicable thermal bloom. Something had dumped a colossal amount of heat into the environment, enough to melt 1 million tons of ice in the depths of a Siberian winter. Another analyst, this one working for the French Directorate General for External Security, cross-referenced the coordinates with thermal imaging data from their own orbital assets. They found it too, a lingering heat signature, not on the surface but emanating from a sprawling semi-subterranean complex of buildings, partially hidden beneath a hillside. The complex was officially listed as a meteorological research station, but the heat it was bleeding into the surrounding rock was not consistent with weather balloons and thermometers. It was the signature of a massive, heavily shielded industrial facility running far, far too hot. The final chilling piece of the puzzle came from below the ground. Seismologists with the Comprehensive Nuclear Test Ban Treaty Organization were asked to check their global network of sensors for any unusual tremors originating from the region, no matter how small. They found one. It was not the sharp, violent spike of an earthquake or a typical underground explosion. It was a strange low-frequency vibrational event, a deep protracted rumble lasting for nearly 90 seconds registered at exactly the time the barium 140 stopwatch had indicated. Its epicenter was located directly beneath the steaming lake and the overheating complex. The evidence was now a tightly woven, inescapable net. The isotopic fingerprint pointed to a unique high-energy reactor event. The atmospheric models had tracked the resulting plume back to a 50-kilometer circle. Satellite imagery had revealed a massive thermal anomaly inside that circle, and seismic sensors had recorded a deep, prolonged structural failure at the exact location at the exact time. The scream in the dark now had a face. It was in the final hours of the 5th day that the team assembled the complete picture, the horrifying truth they had been chasing. This was not a Chernobyl. It was not a Fukushima. And it was not a clandestine bomb test. The data pointed to something entirely new, a nightmare scenario born from the bleeding edge of military technology. The facility in the Ural Mountains was not a meteorological station, nor was it a civilian power plant. The evidence suggested it housed a new generation of experimental reactor, likely a compact molten salt breeder reactor designed for advanced propulsion systems, perhaps for nuclear-powered torpedoes or a new class of strategic drone. These reactors operate at extreme temperatures and pressures, using highly enriched weapons-grade fuel in a volatile liquid state. What the seismic and isotopic data revealed was a catastrophic failure of the containment loop. The deep 90-second rumble was not an explosion in the traditional sense. It was the sound of the reactor's core, a multi-ton mass of molten radioactive fuel and salt heated to thousands of degrees, breaching its primary vessel. A colossal celestial blowtorch of corium burning its way down through meters of concrete and steel, vaporizing everything in its path. As it hit the subterranean water table, the result was a massive explosive steam event, a phreatomagmatic eruption that was not nuclear in origin, but which was powerful enough to rupture the final layers of containment and vent a massive pulse of fission products directly into the atmosphere. This explained the paradoxical signature, the sustained reaction products of a reactor core, combined with the massive spike of short-lived isotopes from a violent power excursion as the core lost its moderation and briefly went prompt, critical during the breach. The scale of the release was staggering. The models, now calibrated with a confirmed source location, indicated that the initial plume contained more radioactive iodine and xenon than the first 48 hours of the Chernobyl disaster, and it had been allowed to drift unannounced and unacknowledged across the roof of the world. The steaming lake was the horrifying proof the facility, in a desperate attempt to cool the runaway reaction and stop the corium from burning its way deeper into the earth, had deliberately flooded the entire underground complex, pumping in millions of gallons of water from the nearby lake, turning the breached reactor into its own toxic boiling tomb. There, in the silent glow of their computer screens, the 3I Atlas team stared at the undeniable truth. They had uncovered a secret, a radiological disaster on a monumental scale, one that an unknown state actor had chosen to hide from the world. A cover-up of breathtaking audacity perpetrated under the assumption that no one would ever be able to piece together the scattered invisible clues. They were wrong. The data did not lie. Each decaying atom of xenon, each whisper of iodine carried on the wind was a witness. And now the scientists who had listened to their testimony were faced with a burden far heavier than any scientific puzzle. They possessed a truth that could destabilize nations, a truth that proved a new and terrifying threat to global safety was not only possible but had already come to pass. The scientific climax was over, but the human drama, the terrifying question of what to do with this knowledge, was just about to begin. And so the silence that followed the final verification was of a kind we had never known. It was not the quiet of resolution nor the calm that follows a storm. Instead, it was a profound, echoing stillness, filled with the weight of a truth we had never thought we would have to confront. The ghost of Xenon-135, that fleeting, unambiguous fingerprint of fission, had not only passed through our most sensitive instruments, but through our very understanding of the universe and our place within it. The 3I Atlas event, which began as a curious astronomical footnote, a blip on a survey telescope, had concluded as a civilization-defining moment, a turning point written not in the grand histories of nations, but in the subtle decay of a radioactive isotope. We were left to grapple with the aftermath, standing on a precipice of awareness from which we could never retreat. The world, in a fundamental way, was no longer the same place it had been before that single anomalous detection. The initial shockwave was not one of panic, but of a deeply unsettling recalibration. For decades, we had operated under a set of foundational assumptions, comforting axioms that governed our search for knowledge and our strategies for survival. We believed we understood the primary dangers, that we had mapped the frontiers of our own technological peril. Our fears were terrestrial, focused on the arsenals we ourselves had built, the simmering tensions between powers, the spectre of our own worst impulses. The sky, while filled with cosmic dangers like asteroids and solar flares, was seen as a domain of natural, impersonal threats. It was a realm of physics, not of intent. 3I Atlas shattered that paradigm with the force of a revelation. It taught us a lesson in humility that no philosopher or prophet could have articulated so starkly. It revealed that our most sophisticated listening posts, our global network of sensors designed to police ourselves, had inadvertently become a cosmic tripwire. We had built a system to detect the whispers of clandestine terrestrial activity, only to discover it could also hear secrets from realms we had only ever dreamed of or feared in our most speculative fictions. This new reality forced an immediate and radical evolution in the very science of detection. The field of forensic nuclear science, once a relatively niche discipline focused on treaty verification and nuclear security, was thrust into the global spotlight. It became the crucible in which our future security would be forged. The data from 3I, Atlas, was not just a result, it was a Rosetta Stone. Scientists from every major institution began a frantic collaborative effort to deconstruct the signal, to understand its every nuance, to squeeze from its ethereal ghost every last drop of information. The challenge was immense. How do you differentiate the atomic echo of a distant, unknown event from the constant churning radioactive background of our own planet? How do you build instruments capable of not just detecting but characterizing such signatures with unprecedented speed and precision? The answer came through a cascade of innovation. We saw the dawn of a new generation of gamma-ray and neutron spectrometers designed not for slow, deliberate orbital surveys, but for rapid response, high-fidelity analysis of transient phenomena. These were not passive collectors of data. They were active hunters, equipped with advanced cryocooling systems to reduce instrument noise to near absolute zero, allowing them to discern the faintest isotopic whispers from the cosmic roar. The computational frameworks underwent a similar revolution. Artificial intelligence and machine learning algorithms, once a promising but peripheral tool, became indispensable. They were trained on vast libraries of simulated isotopic decay chains, learning to identify not just single elements like Xenon-135, but the complex time-evolving cocktail of byproducts that could reveal the nature of the original fission event. These AI systems could sift through petabytes of data from our global sensor networks in mere seconds, flagging anomalies that a human analyst might miss for weeks. They became the silent, vigilant gatekeepers, the digital sentinels watching the watchers. This technological leap was not confined to orbital platforms. On the ground, the comprehensive Nuclear Test Ban Treaty Organization's international monitoring system, the very network that first caught the scent of 3I, Atlas, was re-evaluated and slated for a profound upgrade. Its infrasound, seismic, hydroacoustic, and radionuclide stations had been designed with earthly events in mind. Now they had to be re-engineered to consider vectors and velocities that were unequivocally non-terrestrial. New protocols were written, new response chains established. The organization created to prevent humanity from harming itself found its mandate unexpectedly and permanently expanded. It was now our first line of defense against threats whose origins and motives remained shrouded in terrifying mystery. The science of watching the world had become the science of watching the cosmos, and the line between atmospheric physics and astrophysics had been irrevocably blurred. Every anomalous gamma-ray burst, every unusual particle shower, every flicker in the background, radiation was now scrutinized with a new informed paranoia. We had learned the hard way that ignorance was not bliss. It was a vulnerability of existential proportions. The geopolitical chessboard, already a complex tapestry of alliances and rivalries, was warped into a new and unfamiliar shape. The revelation of 3I, Atlas, introduced a variable so potent, so far outside the established doctrines of statecraft, that it forced an uncomfortable and unprecedented level of global cooperation. Suddenly, the old enmities, the decades of distrust, seemed dangerously counterproductive. The knowledge that a nuclear event could occur beyond the reach of any single nation's intelligence apparatus, a signature drifting in from the void, made the concept of unilateral security obsolete. For the first time, the world's major powers were confronted with a potential threat against which their vast nuclear arsenals, their carrier groups, and their armies offered no defense whatsoever. This shared vulnerability became a powerful, if uneasy, catalyst. Data sharing agreements, once bogged down for years in diplomatic mire, were fast-tracked. Joint research initiatives were funded, pooling the world's best minds in nuclear physics, materials, science, and astrophysics. The very treaties that govern nuclear activity on Earth had to be revisited. How does one verify a treaty when a signatory could plausibly deny a detected event claiming its origin was from beyond our world? The intricate dance of arms control verification and non-proliferation had to learn a whole new set of steps. The logic of deterrence, the cold calculus that had kept a fragile peace for over half a century, was predicated on known actors and rational behaviors. 3I, Atlas, introduced an unknown actor, an event whose very nature defied our models of rationality. It was a wild card that threatened to upend the entire game. This new strategic reality breathed fresh urgency into dismantling the lingering dangers of our own atomic age. The incident served as a terrifyingly effective audit of our own house. It highlighted the precarious state of aging nuclear infrastructure around the globe, the vulnerability of loosely guarded materials, and the ever-present threat of the black market. If a signature like this could be detected from so far away, what might we be missing in our own backyard? The fear was palpable in the corridors of power that the next Xenon-135 signature might not come from the cold of space, but from the heart of a bustling city. The event spurred a renewed and aggressive international push to secure all fissile materials to decommission aging reactors and to develop more robust tracking technologies for nuclear waste and fuel cycles. It was a stark reminder that while we were now forced to look to the stars with a new sense of caution, the most immediate and controllable threat still resided right here on the fragile surface of our planet. The unseen battle fought by agencies like the International Atomic Energy Agency, once the work of quiet inspectors and diligent bureaucrats, was now understood by all as a critical frontline in human survival. And at the heart of this new world stands the global network of sentinels, the silent architecture of our collective vigilance. These instruments, scattered across the most remote and inhospitable corners of our planet, from the Antarctic ice sheet to desolate Pacific islands, are our planetary nervous system. They are a testament to our species' capacity for foresight, a system built not in response to a catastrophe, but in a solemn effort to prevent one. Day and night they listen. They listen for the deep, guttural rumble of the earth shaking from a subterranean blast. They listen for the whisper-low frequencies of atmospheric pressure waves, the inaudible sound of a distant explosion rippling through the air. They float in the deep ocean, listening for the sharp crack of an underwater detonation, traveling thousands of miles through the cold, dark water. And most importantly, they breathe. They draw in the very air you and I are breathing now, filtering it, searching for the telltale atomic decay of elements that have no business being there. They are searching for the ghosts of the atom. The men and women who operate this system are the unseen guardians of our age. They are not soldiers or spies in the traditional sense, but physicists, chemists, engineers, and data analysts. Their battlefield is a screen of data, their enemy a statistical anomaly. They perform a task of immense gravity with a quiet, persistent dedication that goes almost entirely unnoticed by the world they protect. They are the ones who first saw the strange signature of 3I, Atlas, who refused to dismiss it as noise, who followed the protocols and raised the alarm that rippled through the halls of science and government. They are the human element in the machine, the consciousness within the global sensorium. Their work is a sacred trust, a promise we made to future generations after witnessing the dawn of the atomic age, that we would watch, that we would listen, and that we would never again allow the atom to be unleashed in secret. The 3I Atlas event was the ultimate unexpected test of that promise, and it proved beyond any doubt just how essential that silent vigil truly is. It is our shield against the known, and as we discovered, our only window into the unknown. So where does this leave us? You and I, living in the quiet aftermath of that revelation. We are, in a sense, like the first humans who looked up at the night sky and realized the points of light were not lamps hanging in a dome, but distant, suns of unimaginable power. Our universe has once again expanded, not just in scale, but in its capacity for profound and unsettling surprises. We are forced to accept a new, more complex understanding of our own vulnerability. The thin shell of our atmosphere, our lifeboat in the cosmic ocean, feels just a little more fragile now. The silence between the stars is no longer empty. It is filled with a new and potent question. The legacy of 3I, Atlas, is not one of fear, but of a necessary and sobering wisdom. It is the wisdom of knowing that our survival depends on our cleverness, our cooperation, and our unrelenting commitment to looking and listening. The future is a path walked on a razor's edge. On one side lies the immense promise of our science, the ability to read the atomic history of the cosmos, to understand the fundamental forces of nature, to protect ourselves with knowledge and foresight. On the other side lies the ever-present peril, both from the weapons we have created and from the unknowns that still lurk in the great darkness. The work of the Watchers is never done. The monitoring systems must continue to evolve to become more sensitive, more intelligent, more resilient. The global cooperation forged in the crucible of this event must be nurtured and strengthened, for it is our only true defense against dangers that recognize no borders. The battle to secure nuclear materials here on Earth must be waged with renewed ferocity, because the greatest threat is, and always will be, the one we pose to ourselves. We live in a world haunted by invisible dangers. The lingering radiation from decades of weapons testing the slow decay of materials in aging, stockpiles the constant low-level hum of our own nuclear industry. And now the knowledge that other stranger signatures may be drifting towards us on the solar wind. Humanity's journey is a story of learning to see the unseen. From the microbe to the atom to the distant galaxy, we have consistently pushed back the veil of ignorance. Now we must learn to perceive the most subtle and dangerous emanations of all, the faint radioactive breath of a split atom. It is the ultimate signal, the one that speaks of immense power of creation and of devastating destruction. And it is our burden and our privilege to be the generation that learned how to listen for it everywhere. The watch continues. The silence is deep, and we are listening.